Hi, this is Rick for EDU Mobile. I want to kind of wrap up most of the other topics for Swift development in one presentation because they're, for the most part, not very involved, but I do want to talk to you about them and expose you to them so that when you see them in demos and when you see them coming up, you'll know what I'm talking about. So here we go. First, I want to talk about something called any and also AnyObject. Any and AnyObject are types in Swift that are kind of meta types. They refer to multiple types. Any object can refer to any class type, any type that we derive from a class type. And any can refer to any type at all, except for function types that we talked about when we were talking about functions. Functions, obviously, and method types, let's say. The primary use of any and AnyObject are in arrays. So we can do some other interesting things, like return any from a method, and then, well, we can do a lot of things. We can return any from a method in a protocol, and then depending on what that protocol adopts, or what adopts that protocol and implements the protocol method, then it can return one type from one instance that adopts the protocol, and another type perhaps from another instance that adopts the protocol, and so forth. However, again, the primary use of any and AnyObject are in arrays. An array of any can hold multiple types, and an array of AnyObject can hold multiple different instances of multiple classes. So this makes any and AnyObject make an array look something like an NS array in Objective-C, let's say. So now let's talk about is and as. Is tests if an instance is of a particular type, that type itself. And we use it in cases like, if my object is my class, do something. We only do this if the type is unknown at compile time. If the type is known at compile time, we'll get a compile time error. It'll say something to the effect of, this test is always true, and it will be an error, and the code won't compile. So we can use this for runtime introspection. As is a casting operator for instances. We can upcast or downcast using as. Upcasting to a known superclass will always work to a known superclass. And we do this using a syntax like let some instance equal an instance as an instance. The instance is superclass, whatever the superclass of an instance is. So we can upcast, and this will always work. Downcasting, though, there might be a problem. So downcasting to a known subclass, when sure of success, we can use as. But when we're not sure that this is going to succeed, we use the optional form as ? And this will return an optional, and then we will need to unwrap it either implicitly or explicitly. It really doesn't, it does matter, but the as ? we need to explicitly unwrap when we're sure of success. Now we're going to talk about protocols. Kind of a big topic, but we can boil it down to some simple, achievable steps. First of all, a protocol declares properties and methods for instance types to adopt. A protocol declares these properties and methods. It doesn't define them. Protocols declare methods, but don't define those methods. The definition of a protocol method will be left to the instance that adopts the protocol. So an instance adopting the protocol will contain what happens in the method between the curly braces. So protocols can also declare properties that adopting instances must use, and they must use them by name and type. Now, a property in a protocol is specified in terms of getability and or setability, or getability and setability. If a protocol declares a property to be get only, it's a computed property in the instance that adopts the protocol. Otherwise, it could be computed or stored. So let's look at this property declaration in protocols. we have a protocol here called my protocol. A protocol is a type. Anything we can do with type, we can do with a protocol, including things like passing something of that type to a function and so on and so forth. So we have a getSet property here that could be implemented in the adopting type either as a stored or a computed property. Var getSetProp as an int here, and then in the curly braces, the only thing in the curly braces are the keyword get and the keyword set, and that's it. A get-only property that must be computed is listed next. Var get-only-prop. Here it's a float. And then we have the curly braces get. Now, there's no such thing as a set-only property. So forget about that. But we can have getSet or get. GetSet could either be in the adopting type. It could either be a computed property or a stored property. But get-onlys have to be computed properties. All right. So now the types, or type properties and type methods, what we could call class properties and class methods, those static things, in the protocol, they're declared as a class thing, even though the same property or method in the adopting type is going to be preceded by static. So static properties and methods, when declared in a protocol, are declared preceded by the keyword class, but when we get to the adopting type, we use the keyword static. Okay. Now let's talk about extensions. An extension, if you know Objective-C, an extension is like a category in Objective-C. We also had extensions in Objective-C. These are not the same things. An extension in Swift adds functionality to any existing class. We can extend our own classes. We can extend classes for which we don't have the source code. Extensions are the old Objective-C idea of categories, but they're a little bit more powerful. Extensions can add more stuff. They can add computed properties only. Now, they can be computed instance properties or computed static or type properties, but they can't be stored properties. Okay. Instance and type methods can be added through an extension. New initializers can be added. We can add subscripts, which we're going to talk about here in a minute. We can add types inside of types or new nested types. And we can actually make a type conform or adopt a protocol by using an extension. So extensions are very powerful things in Swift. Here's the syntax. It's very simple. There's not a whole lot we need to talk about. Extensions do not have a name. That's probably the biggest thing that you'll run into. Extension my type means we're extending my type. So in Objective-C, we had things for categories like my type plus whatever. Here, the extension does not have its own name. It's just an extension of my type. One more thing, and I already said it, but I want to underline it here. Don't attempt to add stored properties or property observers, either of those two things, to a type using an extension. Can't be done. It can be done by making that type adopt a protocol, but it can't be done only by using an extension. Now, let's talk about subscripts. Subscripts allow us to use a subscripting or square bracket subscripting syntax with any instance type. So subscript syntax is like a hybrid between instance method and computed property syntax. First of all, the header of a subscript looks like an instance method, except it's the keyword subscript. We have a parameter list. Here I've just called that parameter pname, and then it has a type of some kind, and then it returns a type of some kind. And then we have, like a computed property, we have a get clause and a set clause. We don't have to have a get, or we don't have to have a set clause. If we don't have a set clause, then the subscript is read-only. And if the subscript is read-only, the get can be dropped. This is true of subscripts and calculated properties. If a calculated property only is read-only, it can just return what it's going to return. So here's an example of a subscript. I've defined a struct called vector. This is maybe not the best example of this, but it works. We have a vector has a direction and a magnitude. Here they are both doubles. Now we would, at this point, we would have initializers, we would have other methods, we would do a bunch of stuff, but here's my subscript. I'm going to have an index here as a string. We can have an index as virtually any primitive type. So we have an index here as a string, and returning what? We're going to return a double. We're going to return either the direction or the magnitude. And then I switch on my index. If it's R, I return the magnitude, and if it's theta, I return the direction. R and theta, by the way, are kind of well-known subscripts for a vector. So then down in further code, we can let v equal a vector, 3.2, and then pi over 3, where the magnitude is 3.2 and the direction is pi over 3. And then I can print line out v sub r and v sub theta to get this. Notice that r and theta, though, are strings, and they have to go into the subscript as strings. I can use integers as subscripts. I can even use doubles, as I can use virtually anything I want to, as long as it makes some sort of sense. Thank you very much.